2024 marks 3 decades since the Channel Tunnel opened, a monumental engineering feat connecting Britain and France.
This massive underwater railway tunnel crosses the narrowest section of the English Channel, linking two nations.
The tunnel allows passengers and their cars to cross the channel in just over half an hour.
Travelers reach speeds as high as 99 miles per hour, making it the longest underwater tunnel in the world.
While longer tunnels exist elsewhere, none match the scale and complexity of this underwater engineering wonder. Proposed in the 1980s, it was the most expensive construction project ever, famously exceeding its original budget. Despite the financial challenges and delays, the project was entirely funded by private investors.
The project faced significant scrutiny, often being labeled as one of the most expensive white elephants in history.
Yet, it remains a legendary achievement among engineers, representing a triumph over immense technical and geological hurdles. Today, the tunnel is a vital transport link, proving that even the most ambitious ideas can become reality. The idea of a permanent connection between England and France dates back centuries, with many failed plans. In 1802, an engineer proposed a horse-drawn tunnel lit by oil lamps, complete with an artificial island. That initial concept, while creative, was clearly ahead of its time and never came to fruition. Political tensions and fear of potential invasions repeatedly halted various tunnel projects throughout the 19th century. Several attempts were made, but the technology just wasn't ready to make such a massive project feasible. By the 1980s, the development of advanced tunnel boring machines finally made the dream of a channel tunnel possible. These machines were essentially mobile factories, combining drilling, excavating, and lining into one massive, complex operation. The project consisted of 3 separate tunnels, 2 main rail tunnels for service, and a central service tunnel. In a feat of precision, the tunnels bored from both sides met in the middle with incredible accuracy. The tunnel was carefully designed to follow a specific geological layer known as chalk marl, which was stable and impermeable. Even with the right geology, water pressure remained a constant challenge, requiring crews to inject grout to seal leaks. Earth pressure balance machines used hydraulic cylinders to grip the tunnel walls, providing the necessary thrust to advance. Each TBM was a self-contained factory, supporting the operation with cranes, transport systems, and a dedicated crew. The excavated material was transported out and stored, creating new land and even a nature reserve on the British side. To manage air pressure fluctuations caused by trains, engineers installed piston relief ducts between the main tunnels. These ducts act as pressure relief valves, preventing the piston effect that would otherwise impact passenger comfort. Managing heat is also vital, as the friction from high-speed trains would raise the tunnel temperature significantly. To counter this, a massive cooling system was built, circulating chilled water through pipes along the length of the tunnel. Today, the Channel Tunnel remains a vital link, serving as a testament to human ingenuity and engineering prowess.
It is a triumph of modern infrastructure, connecting nations and people in ways once thought impossible. While other modes of transport exist, the tunnel offers a unique and efficient way to cross the channel.
Over the past 30 years, the tunnel has evolved, adapting to new technologies and changing travel demands.
The project's success is a result of the tireless efforts of thousands of workers and engineers. It stands as a symbol of cooperation and progress, bridging cultures and economies across the channel.
Engineering is not just about building structures. It's about solving problems and improving our world.
Thanks for joining me on this look at the Channel Tunnel. See you next time.